Hi, everyone. Welcome to another session of Checkpoints Under the Hood series. Today, we're going to be talking about CloudGuard Network Security and Virtual WAN from Azure. This will be probably one of our longest running sessions with the Under the Hood series is with Azure Virtual WAN. This is probably our 7th or 8th, I would think. Once again, my name is Jeff Engel, Technical Marketing Engineer here at Checkpoint. Before I do the formal introductions, we're going to wait about a minute to let more folks jump in, and then we will get the show started. Thank you for attending, and we will see you in a second. All right, let's get started. So once again, my name is Jeff Engel, Technical Marketing Engineer here at Checkpoint, former customer, former SE engineer, jack of all trades. Here today to talk about our lessons learned, upgrading, roadmap, and Q&A for all things Checkpoint CloudGuard Network Security and Azure Virtual WAN. I am joined today by an esteemed cast of characters. My friend John Guo, Cloud Alliance Architect. I'll let him introduce himself here in a second. Nahali Niogi from Microsoft, as well as Chris Fields from Microsoft, also been integral in the integration and the ongoing development of this joint solution. So, John, I'll let you introduce yourself.
Hey everybody. It's great to be here. My name is John, a Cloud Alliance Architect for Checkpoint. About 20-something years of Checkpoint experience. Over the past few years, been really involved in the Azure Virtual WAN project, helping to integrate the Checkpoint CloudGuard Network Security into the Azure Virtual WAN. So yeah, that's me. Great to be here.
Nahali?
Yes, hi everyone. I'm Nahali Niogi, and I'm a Principal Cloud Solution Architect at Microsoft. My background is in data center networking and security. And in my current role, I enable partners like Checkpoint to design, integrate, and scale real-world solutions in Azure. Thank you, John and Jeff, for your partnership and having me here on the Bright Talk session.
Absolutely. And Chris?
Hello, everyone. I'm Chris Fields. I'm a product manager for Azure Virtual WAN. I work a lot closely with our NVA partners like John, and then I also do a lot of routing features. So a little bit of everything. I have expertise in virtual WAN.
Excellent. All right, so let's jump right into it. I'm going to switch our view. Quick review of the agenda, and then I'm going to do a quick poll before I forget. If I don't do the poll soon, I'm going to forget. So quick agenda, just a quick overview, walk through the upgrade process, lessons learned over the like 3 years since we announced the integration, what's on the roadmap, and then as always, Q&A. So feel free to use the QA panel as we go, and we can either answer them within the panel, or if they are relevant for the entire crew, the entire audience, will stop and answer them live as well. So once again, yeah, feel free to ask us questions as we go. Also, reminder to look at the attachment section. There's quite a few attachments today for a wide range of topics, for the upgrade, for the documentation in general, access to the YouTube playlist for all things virtual WAN and the integration with Checkpoint, et cetera, et cetera. So before we go any further, I'm going to do the poll real fast before I forget. So the first poll question is, what is your level of experience with the current integration with Checkpoint Cloud Firewalls and Azure Virtual WAN? Starting to research, sandbox testing, you're in an active POC, POV, in production, or would like to chat with a Checkpoint and or Azure experts on the design and potential for implementing it into your environment, or also questions around the upgrade process and considerations. So I will leave the poll up and running for at least another minute, and then we can proceed. So I appreciate you answering. Give it a few more seconds, and then we can get going here. All right. So mixture of starting to research, active POCs going on in production. So a good range of attendees today. So appreciate you answering the poll. All right. So quick marketing slides, as you know, and if you've been to these under the hood sessions, we try to make it light on the marketing. I always like to put this slide up there just as another reminder in case you weren't aware. CloudGuard Network Security is purely the standard classic checkpoint firewall technology code base as we use in our on-prem firewalls. The same thing we use in those on-prem firewalls are used with CloudGuard Network Security. The same management, the same policy configurations, the same security efficacy and security quality, everything. It's identical. The only things that are different, honestly, is on the cloud side for drivers or for cloud specific things. But outside of that, the actual firewall code base is identical. Just the names are a little bit different. And if you notice the note at the bottom of that last screen, that is going to be changing here a little bit, relatively soon. So we'll see how that looks, and there'll be around some naming simplification to make it a little more clear. So anyway, just kind of reiterating what I just said. Quantum and CloudGuard, we're using almost identical technologies, but also enhancing on the CloudGuard side, additional cloud native integrations, also a CloudGuard controller, being able to do adapt policies, etc. But bottom line, it's the same technology. And then to tie it all off, a true single pane of glass, same logs, same security policy, all from one place. And also just a nice visual slide showing all the different integrations we have. Basically, wherever you go, we have you covered. And then in regards to Microsoft, we've been a partner of Microsoft's for a very, very long time. Top tier partner, a bunch of integrations, including Azure Virtual WAN, amongst others, a founding member of MISA. Obviously, we're in the Azure marketplace with all kinds of options in the transaction space, whether it's pay-go, bring your own license, private offers, etc. We are a co-sell ready partner as well, and MAC eligible for both for a bunch of products, including CloudGuard Network Security and CloudGuard WAF, as you see there in Infinity. So feel free to take a look there. All right, and from this point forward, I'm going to pass it off to Chris, and I'll jump in here and there, but I appreciate you all attending today. Thank you.
Thanks. So I want to start off giving kind of an overview of Azure Virtual WAN for anyone who might not be aware. So Azure Virtual WAN is a networking service that brings together security, routing, all together in an easy to manage single pane of glass. So Virtual WAN is a hub and spoke architecture with support for branch offices, users, express route circuits, and your virtual networks, all connected in that single easy to use pane of glass. Azure Virtual WAN enables a global construct because you can deploy hubs throughout the globe using Microsoft's global backbone as transit. So those are the big takeaways of Azure Virtual WAN. It's easy to use, easy deployed, fully meshed, and using that Microsoft global backbone. So I will pass it off to John to talk about security.
Okay, so thank you, Chris. In terms of security, securing Azure Virtual WAN, we were first approached by Microsoft about the integration. We're very excited about this because from a security perspective, the best location to secure the virtual WAN is actually deploying our CloudGuard Network Security inside the hub, the virtual WAN hub, like Chris mentioned earlier. And this way, we're able to secure pretty much all the traffic flows, between the east, west, north, south, your branch offices, including your remote employees that are connecting to the virtual WAN. We're able to secure that traffic with ease. And how the CloudGuard Network Security gateways are deployed in the virtual WAN is from a managed application. So essentially, you go to the marketplace, select the CloudGuard Network Security for Azure Virtual WAN, you deploy it, and from there, you can directly deploy it on the marketplace. You can deploy from automation tools like Terraform. In terms of deploying the solution, is super easy. Now, what makes it even easier is the integration with the Azure routing intent feature. Well, the routing intent feature is essentially redirecting your internet and private traffic in the virtual WAN to the checkpoint for inspection. And what's cool about this feature is that you can have it's a little I can show you later on in the slide what the routing intent icons looks like in the portal. But essentially, you have the private traffic and you have the internet traffic, and it's simply selecting the CloudGuard as the next hop for traffic inspection. And then what's also really cool about the virtual WAN is like Chris mentioned earlier, it removes that networking complexity. So as customers add additional branch offices, users, or VNets, even HQ data centers attached to the virtual WAN, that traffic is automatically protected by the CloudGuard Network Security Gateway by the routing intent feature. In terms of licensing, it's a little bit different than what our customers are used to, whereas this is a pay-as-you-go consumption-based license. So you only pay Checkpoint on the traffic that you push to the CloudGuard gateways. Okay, so kind of move away from the traditional, actually, it's not moving away. It's more aligned to how the virtual WAN is charging customers, that we are kind of align our pricing model and our commercial models to the virtual WAN. Okay, so that's the CloudGuard Security Virtual WAN. So here's some of the use cases that we cover. So pretty much all the use cases that are available. So if there are any use cases missing, please do let us know. But over the past few years, we address all the use cases for the traditional east-west traffic, the internet-bound traffic, including the branch-to-branch, branch to the internet. If you're hosting services behind the virtual WAN, we also support direct ingress as well, include the site-to-site VPN and the client-to-site VPN.
So John, here, one additional use case that I wanted to call out is when you have transit connectivity between two express route connected branch, right, with routing intent. So to enable that express route to express route transit connectivity via a firewall appliance in the hub, so in this case, the CloudGuard, you do need to open a support case with Microsoft and be aware that that option is not compatible with global reach. In other words, if you have global reach, then the two express route connected branch will directly talk to each other without transiting the CloudGuards. Does that make sense?
Gotcha. Yep. Gotcha. I actually remember a customer specific calling that out. They're really excited about that ability to inspect traffic that are coming in via two different express routes. So I guess we for those requirements, open a support ticket with Microsoft to get that flow working through the CloudGuard. Is that right?
Yeah, and there are also other implications with how the RFC 1918 routes get advertised towards the on-prem side, and we have this clearly documented, and we'll share those links with you. So just be aware of those caveats.
Okay, gotcha. Okay, so as you can see, we pretty much support pretty much all the flows going through the virtual WAN, and we'll touch base on some of the more details, some of the lessons learned that that we learned over the years, for the past 3 years from our integration later on in the presentation. Okay, so the topic I want to cover, start off with, is the lessons learned, that is the upgrade. So we have two different upgrade options for CloudGuard Network Security Gateway in the virtual WAN. The first is being the side-by-side upgrade, and the second is the in-place upgrade. And that's something new that we just recently published. And so you follow the SK at the bottom, 184687 is the in-place upgrade option. That's something new. And what is the major difference between these two upgrade options is the side-by-side upgrade is you are essentially installing a brand new checkpoint cluster with your target version, for example, in this case here, R82 version. and you can simply go into the Azure portal, go to the routing intent page, and change from the old version to the new. Now, why would you select one over another? The side-by-side upgrade is really giving the customers, help customers minimize that operational risk reduction, right? So the places I worked before, the major financial institution in Australia and also in the US, making sure that connectivity, making sure that the application is not impacted by firewall upgrades is very important for the place I worked at before. So the ability to switch between versions is super helpful. It's kind of like if you think about the old data center where you're upgrading your network gear, you're essentially putting a brand new piece of appliance and you're just swapping the cable. Okay, you just and then if something goes wrong, right, or once they're running a new hardware or new version of the hardware, you just swap the cable back to the old. So the side-by-side upgrade is very useful in that regard, that you can have the business during a change window, have the businesses test on the old version, and then once you change the routing intent, it literally takes about anywhere between 5 to 15 minutes, depends on how many spokes that are connected to the VWAN hub. It takes about 15 minutes for the routing to congregate to the new version and have the line of business test in the new version. If something goes wrong, right, and then during the change window, you're not able to resolve those any challenges that comes up, you just swap it back to the old one. Now, a couple caveats in terms of side-by-side upgrade is that with the side-by-side upgrade, you will get a new public IP address on the new version, on R82 version. Okay, so your external IP address will change once you when you do the side-by-side, when you install a new cluster. Another use case for the side-by-side is increasing or decreasing the capacity. So the only way to increase capacity on CloudGuard gateways, is by increasing the different scale unit or decreasing from different scale units. That dictates the how much throughput you will get from the CloudGuard gateway, the infrastructure, that actually underlying infrastructure that supports the CloudGuard gateways. So that's the side-by-side upgrade. That's something that was in place since we had the integration. Now, what we introduced, the in-place upgrade on the right-hand side, that is really the main objective, is to help customers to preserve those public IP addresses. And over the years, we get feedback from our customer is that they want to preserve the public IP addresses because they have, they're using these CloudGuard gateways to connect to their business partners. They're using the CloudGuard gateways external IP addresses for VPN termination. So in that scenario, in those use cases, in scenarios where if the customer have over like hundreds of different partners that need to update the IP address, it makes updating these third party on the partners' IP addresses is quite a bit overhead. So we work with the team to provide a safe in-place upgrade method to help customers upgrade from the old version to the new, while still preserving the public IP. Okay, so that's the in-place upgrade. So if you follow the SK article below, 184687, it'll bring you to the SK, the how to go about upgrading. And I'll touch base on some of the details on how it works in a second.
So John, here, yes. The inbound IP address is preserved both with side-by-side and in-place upgrade?
Yes, thank you. Yes, the inbound IP address is actually owned by the customer. So those IP addresses will get preserved between the two different upgrade methods. And I'll touch base on how to do that in a second. Yeah, thank you for calling that out. Okay, so diving a little bit deeper on how to do a side-by-side upgrade. So you first go to the Azure marketplace, install a brand new cluster, right? So either you increase the capacity or change to the upgrade to a different version. You can have both in the same hub at the same time. The only time it changes is when you change the routing intent. So you can have 2 or 3 or 4, but the checkpoint will not be charging you on the additional cluster that you install. But however, there will be an infrastructure cost behind that. So the first step in a side-by-side upgrade is to install a brand new cluster side-by-side. And then second is to set up the internal security, internal communication between the management station and the gateways, and you install a policy. So safest way to do it is that you install the exact same policy that where you're currently running in your existing cluster. Install the same policy on it. And at this point, like Harley mentioned earlier, is when if you have any ingress public IP addresses that are being used, you can change from the old version to the new version, right? And this step, you will start incurring outages. So this is advice you do during a change window, right? So step number 3 and 4, schedule a change window and do this work during a change window. So you can change the public IP from the old cluster to the new cluster, and then you will change the routing intent from the old to the new. So all of this takes about 15-20 minutes or so. Okay, so that's a side-by-side upgrade. All right. So this is what it looks like. So once you onboard the new cluster, so in this case I call it ingress cluster 1, and you onboard the new cluster to the management station. You push a security policy, make sure everything is turned out green and healthy. And at that point, you're ready. Then you go to the Azure portal, navigate to the VWAN hub itself, and navigate to the routing intent policies. And this is where you change from the old cluster to the new cluster. Okay, so it might be a little bit small here, but you select the network virtual appliance, and the next hop resource, select the new cluster, right? Select the ingress cluster. Okay, so that's the side-by-side upgrade. And again, what's cool about this upgrade is that if there's anything wrong with the new version or any application is not working, you need to roll back. You can simply change the routing intent from the old to from the new back to the old.
Hey, John, real quick before you keep going, there's a question in the queue about migrating the PIP in the side-by-side once you have completed the upgrade. Do you want to answer that live?
Sure.
What's the very
question?
top.
Yeah.
It's asking, can't you migrate the PIP in the side-by-side once you have completed the upgrade?
Yes, that's possible. Yes. So you don't have to change the PIP right away. The only caveat is that you will need to delete all the load balancing rules. Once you delete, then you can move. But if you're gonna keep the cluster in there anyway, the old cluster, then you can move the routing intent from the old to the new, and then take your time moving the public IP addresses over.
Thanks, John.
Yep. Okay, so let's dive a little bit deeper under the hood of what the in-place upgrade looks like. So again, the in-place upgrade is, the main use case here is to preserve the public IP address of these NVAs. And I'll show you some of the ways to help you minimize some of the risks and give you the benefit of the side-by-side as I go through this upgrade path, what it looks like. So so starting from left to right, we have the X mark here, essentially disabling the health probe from the load balancer, is to remove this RAD1 gateway from the backend pool of the internal load balancer. And what that will give you is that the load balancer will no longer send your production traffic to the gateway that with the health probe disabled. So give you the time to do the upgrade, so that it will not impact your production traffic. And the SK article outlines the ways to disable the health probes, and we even gone as far as have a connection draining, right? Wait enough time for that all the existing connections are drained from the gateway, so that you don't impact any potential production flows. So once you remove the help probes, this gateway will just sit there until you click on the upgrade button. So there are a couple of ways to upgrade. Obviously you'll need to transfer the in-place upgrade using manually by CLI over SSH, or you can use CP use feature to download the latest version and click on upgrade. Now the duration it takes, now the file transfer, I think it takes the longest time. So it depends on your bandwidth, right? So I would suggest to download all the upgrade packages to all the gateways that needs to be upgraded, and then when you're ready, click on the upgrade button. And in our labs, we're seeing anywhere from 10 minutes to 15 minutes to upgrade from 81 to 82. So allocate enough time for your change window to cater for that. So after the gateway is upgraded, you go through the Smart Console, update to the old version to the new version, 82 version. And then from there, you can re-enable, once you're ready, right, then you re-enable the help probes so that the traffic will be sending to the R82 version. Now, there was a question, Holly, from our previous discussion that we came up, say, hey, can you run 2 different versions at the same time? Right? And the answer is yes. Some of the ways, is to minimize some of the risks, is that you can have 2 versions running at the same time. So, and then Holly also called out earlier before webinar starts is that, you will be running in a single gateway or, kind of a degraded
Degraded
gateway.
mode, yeah.
Degraded cluster. So if the volume of traffic that you need, that, it's better that you enable both. But if the volume of traffic at the time allows for, then you can actually run both at the same time. And you can even go as far as turning off R81 version, have your line of business test through the new cluster, the new R82 version, make sure that all the application works before you start on the R81 version, the other firewall 2 in this case. So the same process applies, right? So once you're ready, then you can disable the help probes on the firewall 2, upgrade, wait for the connection to drain, upgrade this firewall 2 to R82, and then we enable the help probes once you're comfortable, and then now that you're completely running in R82. Okay. So some of the considerations, helpful tips in terms of in-place upgrade. We need to make sure that your disk space, you have 15 gigs of disk space in Volog directory. In the SK article, we also have steps on how to clean up the Volog directory to give you that 15 gigs of disk space. During the preview, we did have some customers mention about like, hey, I tried, I just can't free up enough disk space for the installation. Then what you can do is that you can actually use the re-image feature from the Azure portal. So you can actually turn the gateway back to the factory default where there's going to be plenty of disk space in the Volog directory. However, you will need to restore your configuration if you use the re-image feature. The restart and re-image feature also come pretty handy, right? If during the upgrade process, if the NVA become unresponsive or is not coming back from a reboot, you can leverage the restart and re-image feature to restore that NVA back to the factory default. Again, you will need to restore the configuration and to resync the gateway to the management station and push policy to it, and then run the upgrade process again. So there is something to help alleviate some of the risks in terms of doing an in-place upgrade. You do it this way, and along with having the users to test on the new firewall version as well. Some of the best practices is that make sure that you have your application owner test all the traffic before the change window starts, and have the exact same users and application owners test their application after the upgrade, so that there's no confusion as to, hey, did the firewall break something from the upgrade, right? So if you identify all the key business applications are tested before and after, then usually, at least in my experience, that addresses a lot of the some of the confusion, some of the things are not working that blaming the firewall. So that comes up a lot, at least the time that I work in operations. It's also good to back up your existing configuration. Again, you will be if you end up using the reimage feature, you have a backup of the configuration to restore. We are going to be we just didn't have enough time to publish, so we have the pre and post upgrade verification. That we do have a little script that will help customers to do like a quick snapshot of the gateways before and after. We'll share that in the SK article in the coming weeks. Okay, so that's the upgrade. Jeff,
real quick. Yeah, there's a few in the Q&A if you want to take a peek. Otherwise, I can just ask them to you live here. I'll ask one. In the case of side-by-side upgrade, can we move a pool we already use to the R82 instance or R82 version?
A pool.
I'm saying
like a back-end pool.
I'm pretty sure he means an NVA. I'm sure he means an NVA, configuration.
That's a really good question. So, a pool. So there is no way to set up another cluster as in a back-end pool. You change the pool, the load balancer change from this back-end pool to another. We don't have that granularity in the virtual WAN. However, you can change. Actually, sorry, let me take it back. Side-by-side upgrade is, yes, side-by-side upgrade is that you install a brand new cluster anyway. So let's say you're currently running R81. With a side-by-side upgrade, you install a brand new cluster, an R82 cluster, and you use the routing intent feature to change from the old to the new. But we don't have granular access into the load balancer itself for the side-by-side. But it has to be done from a routing intent. I hope that answered the question there.
And then another one, I don't know if you're looking at the questions I'm seeing here. So another question, can I trickle only part of the traffic to the new firewalls, to the new NVA configuration?
Yes, you can. So let's say in this scenario, if you look at the last, like both R82 version. So let's just say the firewall 2 is R81. And then you also have R82 running. What you can do is so there's some critical applications that you need to test on a new version. If you identify what VNets they belong to, you can essentially create a UDR, user-defined route, point it directly to the R82 instance internal IP address. So that way, all the traffic from this VNet will go to R82 version. And then this will allow you to test the traffic for this one specific application on R82 only. I hope that makes sense. And if you have any more follow-ups, you feel free to reach out to me, and I'm happy to dive in and show you how to do that. But yeah, to isolate to only one gateway, there's two ways, right? One is using UDR. The other is that you can take down the R81 version from the disabled health probes on one of the gateways or all the other gateways and just test on a new version. You can achieve what you're looking for that way as well. So there's two ways, UDR or just take down one of the 81 version. If that makes sense.
Great.
Okay.
Thanks, John.
Yep.
All right. So second poll question before we continue. Starting it now. Is the in-place upgrade process, now that you've seen us talk about it and discuss the various components of it, Is the in-place upgrade process clear? Yes, it's clear, mostly clear, but need to review the documentation. I have a few concerns, need to review the documentation again. And lastly, would appreciate some assistance from Checkpoint and Azure experts on the upgrade process. So I will leave this poll open for another minute or so, and then we can proceed. Appreciate everyone answering if you can, but it's not required, obviously. Thank you. Sorry, I've been talking this whole time and you can't hear me. I stopped the poll. For the most part, everyone is happy with the steps of the process. It's clear. There are a few others that do have some concerns, but we'll take care of you regardless. So appreciate the feedback, everyone. Thank you. So we can proceed. Thanks, John.
Okay. All right. So it's been 3 years since our integration to virtual WAN already. We want to share some of the lessons learned working with various customers and stuff. And my daughters are now actually taller than my wife. And my lesson learned is don't poke the bear, otherwise all three of them come after me. So so a lesson learned. I just can't believe this time just flies. Okay. Lessons learned. I'm going to start off with the public IP addresses. So we get a lot of questions around this. The ingress public IP address is owned by the customer. And this is something that you have full control over. What you do is that you create, you can, obviously bring your own IP addresses to Azure, or you can create a public IP that is attached to your subscription. So you, as a customer, you have full control of the ingress public IP address. Now, some of the confusion comes like, well, is the egress public IP address, that is something that is cannot be carried over from one cluster to another. So hence the the in-place upgrade methodology that we created. So the egress public IP cannot be changed between the checkpoint clusters. So as you scaling up, or you deploy a brand new checkpoint cluster, those egress public IP addresses will eventually move. The old public IP will go back to the Microsoft IP pool space, and then the new cluster will not necessarily get the same IP address. So just want to clear that about the public IP addresses, and then I'll pass it on to Chris about the virtual WAN hub address space.
Sure, thanks, John.
Yeah.
So as I talked about before earlier in the presentation, virtual WAN is a network service that brings together all these different components, right? So when you go through the process of creating a virtual WAN hub, we actually ask the customer, hey, what size address space would you like to allocate for the hub? And then once we do that, we start allocating on the back end, we start allocating subnets for different things. So we allocate subnets for VPN, for ExpressRoute, for NVAs, and everything is scaled proportionally. One of the lessons we learned was working with Checkpoint. We noticed that some of our customers were having these deployments that were bigger than the address space they allocated. So, they would allocate a /24, and then once we had all our subnets allocated, they would come back to Checkpoint and to us and saying like, hey, we ran out of address space. Like, what are we supposed to do? Like, we didn't know we had to think about this. So, working with John and the product team, the Checkpoint, everything like that, we actually looked into how we recommend customers deploy things, and we improved our recommendation. So now we recommend the /23 for all deployments across the board. And then we've also done a good job of outlining in our documentation that customers should think about, hey, if you plan on deploying an NVA, and if you plan on scaling to, a certain IP range or a certain range, that you should think about how much IP address you should use before you even deploy your hub. So this was a great learning. It definitely helped a lot. It saved a lot of support tickets and headaches on both the Microsoft and Checkpoint side. So now now we have this nice fully fledged documentation to send customers to before they even deploy their hub. So we can nick these problems in the bud.
The hub IP addresses, sorry, so go back to the slide there. So thank you, Chris, for that. And from a Checkpoint perspective, if you are running, we'll be integrating our SD-WAN solution into the VWAN hub itself, and that will require using a third interface. And we'll be allocating those IP addresses from the subnet range on the right-hand side, IP addresses available for NVA, external subnets. So we'll be allocating IP address from this pool. So you plan on supporting SD-WAN in the future. So I would suggest to select like at least the /20, just to give you enough space so that you can, do the side-by-side upgrades if you need to, and allocate enough space for the SD-WAN integration if you want to do that later on. So I just want to call that out. So thank you, Chris.
Mm-hmm.
Okay, so next we want to some lessons learned about securing the private endpoint. So Holly, want to lead us through this, and then we can discuss.
Sure. Thanks, John.
Yep.
Yes. So the scenario over here is securing the private endpoint, and when you have a combination of VWAN hub and routing intent. So in this picture, on the right-hand side of the diagram, you see a branch 1, and then you see a VWAN hub at the top, and there is a little private endpoint icon in VNet 2. So one of the lessons that we learned is that think of the flow of interest in this case as starting from branch 1, so 10.21.4, hitting the private endpoint in VNet 2, which is the 10.10.2.5. Right? So that's the flow of interest. And how do you secure that flow? Right? So there are two ways to do this. You could use the NSGs on the private endpoint itself, or you could steer the traffic through the CloudGuards. Now, the important thing to note over here is that there is a default behavior, which is often missed, which bypasses the CloudGuard. And John, if you wouldn't mind, I want to show a setting, which is a subnet level setting. If you want to go to the next slide. So what you see in the right hand side, the red box, is a subnet level setting on the private endpoint subnet, where by default it is set to disabled. So when it is disabled, it bypasses the CloudGuard. So that's something you need to be aware of. So if you do want it to steer that flow, so going back to the diagram, John, the flow from branch to the private endpoint, if you want to steer it through the CloudGuards, you need to enable that route table checkbox. Now, there are various other flows. Sean and I have done a deep dive video with packet captures, and if you love looking at packet captures like John and I do, be sure to check it out. But we've done a deep dive video where we have documented this behavior for each of the different settings. And John, any other flows you want to talk about from the previous slides? I know you tested a lot of them.
Yeah. So we spent time working together with Holly, test all the flows, how to secure the private endpoints. So from all the VNet from all the VNets are connected in the spoke VNets, including all the VPN connections, either client to site or site to site VPN coming in. We are able to redirect the traffic to the CloudGuard security gateways for inspection. What that will give users is the ability to define access control on the CloudGuard gateways to the private endpoint. So sometimes users use the user authentication, like permitting only certain users access this endpoint. You can actually enforce that from the CloudGuard gateway. So pretty much all the flows here, all the use case highlighted here, we've tested all, making sure that all the traffic will be inspected by the checkpoints and to provide the access control to the endpoints that you want to publish.
And going back to that setting, John,
yes.
Another lesson that we learned, and we worked with another large customer, a joint customer of ours, where their branch was express route connected. So the behavior is different when your branch is VPN connected versus express route connected. So what we notice in an express route connected branch is that if that setting is disabled, the private policy setting is disabled, the flow from the branch to the private endpoint bypasses the CloudGuard, but the return traffic will hit the CloudGuard. So it was getting asymmetric and it would break the flow. So remember that if you do have an express route connected branch hitting the private endpoint, that option, if you wouldn't mind going back to the previous slide, John, this option should be set to route table, the network policy for private endpoints that should be set to route tables, because with express route, it will break the flow. Okay, so that's something we learned, and we have done this video, so be sure to check it out. We have the link in the next slide.
Yeah, so we follow that link, take us to that video, and yeah, a lot of packet captures. I remember that in that video. So.
Yeah, asymmetric traffic with express route is the key there.
Yep. Okay. Okay, so next topic is securing FTP traffic in virtual WAN. This came up quite often over the years, is that the customers are still using FTP, and we understand that sometimes might be out of your control. But if you are in control of that FTP server, I suggest to change to SFTP. Is more secure and it's more reliable, right, in terms of transferring data. I would say more reliable, but less complicated, I would say, than FTP. So the challenge with the virtual WAN and FTP's traffic is control and data channels might end up in different CloudGuard gateways from the 5-tuple hashing of the internal load balancer. So in some of the scenarios, testing we did, and again, a lot of packet captures and with Nahali, we identify that regardless of active and passive FTP, the only way to get this to work, I would say the most reliable way to get this to work is to isolate the traffic to the single CloudGuard instance, where all the FTP, the control and data connections are going through the same CloudGuard gateway. Because we're using the same code as on-prem, like FTP has been around a long time, so is our firewall. So we have mechanisms in FTP protocol detection to allow that traffic to get through without too much fuss, but we have to keep the traffic symmetry to the same CloudGuard gateway. So in order to do that, one way of doing it is using to advertise the routes from the CloudGuard gateway to virtual WAN, and that will update the virtual WAN route table to send traffic to the CloudGuard gateways and to the first CloudGuard gateway here. So as you can see, all the arrows are the connection. So essentially bypassing the internal load balancer. That's the angle. We're trying to bypass the internal load balancer. so that the traffic to the remote FTP server will be going to the CloudGuard gateways first directly, and will HiNAT it out to the FTP server and allow it. And when the FTP data channels and control channel ports change, we're able to track it dynamically from the single gateway. So the biggest challenge here is the 5-tuple hashing. Is that so some of the traffic may end up in a second CloudGuard gateway, so therefore you break the FTP connection. Now, we're also doing it this way also provides resiliency as well. So in case the first CloudGuard gateway is down, BGP will fail over the traffic to the second CloudGuard gateway, because we're going to be using AS-Prevent 2 to set the priorities to the secondary gateway. Now, some of the consideration is that the FTP server FQDN. So when we proposed this solution, some customer came back and be like, well, the FTP server IP address changes from time to time, so this solution is not great. And yeah, we understand that, and it's something that will require an external mechanism to trigger the IP change. So that will we can update the BGP advertisement. Yeah, this is what we can think of, right? And obviously there are other options such as using UDR as a way to force traffic to a single CloudGuard instance, but we'll lose that redundancy with the in case one of the fails, that UDRs cannot be updated dynamically. So this is the best way that we come up with to address the FTP use case. Okay.
Yeah, John, just wanted to add a couple things of the behavior that we had labbed for this particular customer. Was that particularly with CloudGuards in VWAN, I wanted to differentiate that the CloudGuards in VWAN, what happens is that the control channel was going through one CloudGuard and the data channel traffic was going through the other CloudGuard. And we were getting that classic data peer IP differs from control peer IP message, right? So just be on the lookout. If that happens, that means that's what you are hitting. And unfortunately, with the VWAN, you don't have access to the internal load balancer that John has on the slide. So you could not change the 5-tuple hash to 5-tuple hash to 2-tuple or 3-tuple. If you do that, it will work. So in other words, if you have a classic load balancer sandwich design outside of the VWAN, you can adjust the hash, and it will still work. And so just wanted to make that distinction there. Hopefully, John, we can do a deep dive video on this. We were able to lab it before, so.
Yep, 100%. Yeah, sounds like a really cool video to do. So, and we have it all set up already. So, and we can just touch the recording. So, but yes, this is addressing the FTP use case. I'm just conscious of time here for 6 minutes left on the webinar.
Yeah, I was just gonna say time check because we actually have a bunch of good questions in the queue as well that we want to take a look at as well before we proceed.
Okay.
Or we can go to the next slide and probably knock that out, and then we'll go to the questions.
Yeah. So just this next slide here is just really to highlight the restart and reimage feature available. So make a note of this. If you reimage, you're going to have to restore any post-deployment configuration, resig, and install the policy again. And obviously restart, just a restart. Okay, just real quick on the roadmap. So from a checkpoint perspective, we are targeting to support SD-WAN in Q1 26. So we're fleshing out a couple other corner cases there. Then we'll be ready to fully support the SD-WAN in CloudGuard in the virtual WAN. And then Chris, the Azure virtual WAN. Yeah.
Yeah, so a few features in the roadmap I wanted to call out was force tunneling. So force tunneling is the use case where customers, where before in Azure, if you had a default route, it would basically send all traffic to the internet. With force tunneling, you can select the next hop, the default route's next hop to be the firewall, and then from there, the firewall can send traffic back to on-prem or wherever it was. This is a very good use case for if for compliance or security reasons, you can't send your next hop traffic as the firewall directly to the internet. It needs to go somewhere else beforehand. So that feature is GA, and the link to the documentation is included in the slide. And then we also have a lot of customers asking for IPv6 support. IPv6 support in virtual WAN should be in preview, hopefully sometime in the spring, with a GA date targeted towards the end of the year, hopefully fall or winter.
Cool. Thank you, Chris.
Cool.
All right, so let's stop here for a second and jump into the Q&A. There's a bunch of stuff in there. So feel free to take a peek, and then we can walk through them live if need be.
Okay. Let me see here. So the first question is the egress traffic limited to the NVA public IP, or can additional public IP be added to large deployments? Answer is yes. So you can attach additional public IP addresses to it, so that we'll use those public IP addresses for source NATing. That this will alleviate from the port exhaustion that you'll run into. So yes, to answer the question, yes, you can add additional IP to the NVAs. There's a lessons learned. Someone shared lessons learned about using remote access VPN on the CloudGuard gateways. During the pairing configuration, make sure to use a full pairing instead of subnet to subnet pairing, as the office mode IP subnet is not part of the specific VNet subnet, which you might peer. So thank you for sharing that. This is very helpful. So in the Checkpoint Remote Access VPN, we have something called the office mode. Office mode is an IP address range that we assign the remote VPN users when connecting to the CloudGuard gateways. And this call out here, lesson learned, share, is that making sure that the when you peer to subnet, making sure to use full pairing instead of subnet to subnet pairing. So thank you for sharing that. The next question is there a dedicated management interface for the firewalls deployed in the virtual WAN hub? The answer is no. You can manage from the external IP address and the internal IP if the routing permits. So typically, customer will manage it from the external. So no, there's no dedicated management. So there's a question: can we deploy an external load balancer to share the same public IP address to the internet, to the cloud or internet? Right. I think that's the question there. This way, we can also do a side-by-side upgrade without changing the external IP. That is achievable outside of virtual WAN. You can hide that behind the external load balancers public IP, but we can't do that in the virtual WAN deployment. So that's a really good question. But yes, we have considered that in the past. So there's a question about BGP and SASE and having the active-active The way we solve that is using BGP AS prepend to set the priority and to pin the traffic to a single CloudGuard gateway from the active-active. So we're not able to achieve the full active-active with like BGP ECMP, for example, where traffic can be shared between the CloudGuard gateways. But we are able to pin the traffic to a specific CloudGuard gateway for any SASE type related traffic or any traffic they want to only have a single CloudGuard gateway to be handled. We are advertising those IP ranges to the VWAN hub to send the traffic directly to the CloudGuard gateway. It's kind of like that, similar to how we solve the FTP server problem, where we're using the BGP to advertise the IP ranges to a single CloudGuard gateway, and then we use AS prepend as a way to set the priority between the two gateways and the failover between the two. Hopefully that answered your question. But do feel free to reach out to me if you have any follow-up, on the design and how that works. We do have an SK. If you look at our site-to-site VPN for Azure Virtual WAN, that is the mechanism that we're using to pin the traffic to a single gateway. So you follow the SK. If you have any questions, reach out to me, and happy to work with you to flesh out that design. The last question.
I was looking into that as well, John. So in VWAN, it says new subnet bypasses the CloudGuard. So in VWAN, once you define the private traffic going through the CloudGuard, it will go through the CloudGuard. I couldn't quite understand the question. Maybe it needs a little more.
Yeah, so we can reach out to you on that and get more and expand on the use case. I won't say your name out loud. It is private, so we'll reach out to you directly and get to the bottom of the use case and see if we can help you out.
Yeah. So I have some ideas, but I just want to fully understand your question before I answer. But yeah, we'll reach out and to further understand the use case there.
All right, before I let you guys go, one last poll question. Sorry, unless somebody had something else to say, real quick.
I'm good. Thank you, Jeff.
I don't want to interrupt anybody. You guys good? Okay.
Yes, thanks, Jeff.
All right, real quick. So last poll question, and go ahead and start it. Would you recommend the integration of Check Point's Cloud Firewall, aka CloudGuard Network Security, and Azure Virtual WAN to a friend? First answer, calling my friend right now. Would recommend. Is promising, but would explain the caveats and needs a little improvement first. So we'll leave this poll open for another minute, and then we can hustle through. If there's any more questions, feel free to ask them now. We don't want to keep you a whole lot longer than we need to, but really appreciate everyone attending today.
I'm going to call my friend Jeff.
Yeah. Yeah, from my perspective, I mean, everybody, this is just my 2 cents, and this is my thoughts all along. Is everyone's looking for an easier way to do the cloud plumbing, and then you can add security to it. It's just a no-brainer. It's really slick. So it's definitely it's a good integration. It's a great integration, and it makes everyone's lives easier, in my opinion. And whatever we can do to help with that, and then also apply security quickly and easily is even better. All right, we will give it another 5 seconds and stop the poll. The majority say would recommend, so that's awesome. I really appreciate that. And there's a few with is promising what would explain the caveats, and then there's a few others that say it needs a little improvement, which we appreciate that feedback as well. So it's all good. You're never gonna be perfect, so you can always just strive for that perfection. We'll get there at some point. So as always, stay tuned for our next Under the Hood sessions. We'll be covering a range of topics. Really appreciate you attending. Feel free to give us feedback within the Bright Talk session. Let us know what you want to, what other topics you want to hear about, including, more topics in the Azure Virtual WAN space. We've done a bunch of these. Just a reminder to look at the attachments list. You should find links to almost everything we talked about today: documentation, SKs, a link to Checkmates. We always got to shout out Checkmates. If you don't know about Checkmates, that's our user forum community. Very active. A lot of really smart people out there. R&D watches that closely. I think we get more traction from that than we do from when we complain internally. So please feel free to provide your questions and feedback there as well, or improvements. It's a good resource, great resource. Any other closing thoughts from the panel, Chris, Nahali?
No, I just want to say
John?
thank you for Jeff, and thank you, Chris and Holly, for your partnership. And looking forward to the deeper integration that we can do together.
Of course.
Absolutely.
Happy to be here.
Yeah.
All right. Well, we will close her down. Thank you again. Take care.
Okay.
Thanks, everyone.
Thanks. Bye.
Bye-bye.